Hi, in this video I'm going to introduce you to generic collections. .NET provides multiple namespaces for collections. System.collections includes interfaces and classes that define collections of objects. Today, those are mostly used for legacy code because early on in C# 2.0, generic collections were introduced. You find them in the System Collections generic namespace. In our course, we focus on the collections defined there. Be aware, though, that these generic collections are not well suited for multi-threaded programming. If you ever need thread-safe collection classes, check out the namespace System Collections Concurrent. Let's have a brief look at system collections. To Java developers, the class names look quite familiar, especially ArrayList. Be aware, though, that you're looking at collections of objects. They require a lot of boxing and unboxing for value types. In any case, make sure to use generic collections when writing new code. They provide compile time safety and they perform better. Before we look at the namespace System Collections generic, let's take a moment to compare generics in C# with Java. In Java, the compiler applies type erasure. This means the type parameters are substituted with their specified bounds or with class object, and casts are inserted whenever needed. C# implemented generics in a different way. In C#, the JIT compiler creates the actual classes based on the type specified. That means, if you use in your code a list of circles and a list of squares, two separate classes are generated, a circle list and a square list. Creating these type-specific classes allows C# to efficiently use both value types and reference types as type arguments. Let's look at an example. If you try to create a new array list of type int in Java, this won't compile. Java only accepts reference types as type arguments. However, if you create a new list of type int in C#, this works perfectly fine. Note, though, that in C#, list is a class and not an interface like in Java. In C#, the corresponding interface is called iList. Now that we had a moment to compare generics in C# with Java, let's have a look at a small selection of classes in namespace System Collections generic. We have two lists. The linked list is doubly linked. There are classes to represent a queue and a stack, and at the bottom we have three classes that represent a dictionary. All three of these implement the interface iDictionary, but they use different data structures in their implementations, which lead to different performance characteristics. Take a moment to look at the documentation. I think you'll find it interesting, especially when you have already taken the Algorithms and Data Structures class. Now we're going to have a look at four common collection interfaces: iEnumerable, iCollection, iList, and iDictionary. iEnumerable has only one method. We'll look at that in a moment. iCollection extends iEnumerable. That means it inherits the method from iEnumerable and it adds its own interface members. iList extends iCollection, and by doing so, it also extends iEnumerable. The same is true for iDictionary. Here we have the four interfaces again, but this time we'll add more detail. The properties we list at the top. and the methods will list at the bottom. Here you can see the interface members of IEnumerable. It is one single method and it is named getEnumerator. iCollection extends IEnumerator, which means it inherits all its members and it adds some additional new ones. iList extends iCollection. It inherits all the iCollection interface members and adds its own ones. iDictionary extends iCollection. Again, it inherits all the iCollection interface members, and again, it adds its own ones. One property that I want to point out in particular is the item property. It enables the user to access a specified element by using an index in rectangular brackets, just like we access elements in an array. Here is an example. I have a list called myList, and I use the item property to access the third element and to assign it to a variable called x. iDictionary has an item property too. In case of iDictionary, we provide the key inside the brackets in order to look up the corresponding value. Let's look at another example. Here I have a dictionary called phonebook. It stores my friends' names and their phone numbers. I use the item property to look up Ben's phone number and I assign it to a variable called n. There is another property worth mentioning, and it is count. As the name suggests, it gives us the number of elements contained in the collection. The reason I point it out is the following. All classes that implement iCollectionT have both a property count and a method count. Always use the property. It is more efficient. That being said, you might ask, why do we have a method count if we should not use it? The reason is the following. There is something called standard Curie operators. Those are methods that provide Curie capabilities like aggregation, filtering, sorting, and more. Many of these methods operate on objects that implement IEnumerable T. Some of these methods are minimum, maximum, average, and also count. So please keep in mind when working with iCollectionT that we always want to prefer the property count. The methods have pretty self-explanatory names, but let's have a brief look at the method add. It has special importance because it is used by the collection initializer. If a collection implements the generic interface iCollectionT, it has this add method and it can be initialized with the collection initializer. Let's look at an example. The variable L is of type iList because it is a good practice to program to an interface. As we declare L, we also initialize it with the list that contains the elements 1, 2, and 3. The collection initializer looks very similar to the array initializer, except that we also had to specify which collection we were going to initialize. Some collections don't implement iCollection. If they implement IEnumerable and they have an extension method add, then they can still use the collection initializer. However, some collections just don't have an add method, and in that case, the collection initializer cannot be used. Examples of such collections are queue and stack. Here, I tried to create a stack. Using a collection initializer did not work because class stack doesn't implement the generic interface iCollectionT, nor does it have an extension method add. Because of that, I need to create a stack and then add all the elements. If you paid close attention, you might have noticed that I declared S of type stack rather than programming to an interface. That's because there is no interface iStack, and I wanted to use stack-specific methods like push and pop.